So, welcome to the afternoon session. We move on to a slightly different topic. So this morning we talked about customers and changing customer expectations. And of course, one of the changing expectations we see a lot of is requirements for low-carbon concrete. And that's the topic of the next panel. So if I could welcome the panelists onto the stage. I'm very happy we have on stage three panelists who have quite different, if you like, ideas and backgrounds, all of them thinking about this from the standpoint of concrete rather than cement. And I think it's important for cement producers to look at it from this perspective, because obviously when you look at it from a cement perspective, you're thinking about reducing the CO2 footprint of the cement. But we shouldn't forget, at the end of the day, our end users are using concrete, and there are other ways of producing concrete that we should be well aware of. So we're going to start this afternoon with Thomas Atkinson, and Thomas is from Hoffman, and Hoffman, as you probably remember from last night, won one of the awards. So Thomas is going to talk about their approach to low-carbon concrete. Thank you, Thomas.
Hi everyone, and thank you again for the award given yesterday, which is a great achievement for us to be represented as a proper cement, because as you may know or heard already last year, we are providing a clinker-free cement. So this is our Hoffman DNA, is to get rid of all the clinker. By doing this, we divide by 5 directly the carbon footprint of cement, obviously, because we avoid all the killing. So we say it's 252 kilos per ton of cement that we produce. This is a French number because we have an allowance for the slag of 1.4% of the steel industry carbon footprint to allow, which is not the case in any other countries now. So we're down to 188 kilos of CO2 per ton of cement that we produce, and even go down to 142 for the H-Iona cement, that will be the yellow technology, which is also a slag based, but to be fair, it has 0.5% of clinker in it, just to fit within the norms that we don't actually need for the this slow kinetic cement, which is a super sulfated cement. How do we do this? Well, basically by getting rid of the clinker, we're getting rid of all the quarry and the kilning process. So as you see, most of you, obviously you know what a traditional cement factory is. We got rid of everything regarding kilning and burning the clinker and the limestone. So what we have today is what we have here on the tower, which is a 250,000 ton production capacity tower, using gravitation to pull all the powders down to be melted and directly into a truck. With this system, it's fully electrical, so we are autonomous on 50% of our needs in energy, and it only takes 2% of costs into energy. Okay. To provide our cement, we only need 88 kilowatt hour per ton of cement that we produce. Hence the reason we can go so low in carbon. Another key element is that these 188 kilos per ton is a non-compensated figure. Okay, so we do not buy any carbon credit or plant trees on the other side of the world to get that number. Last year I just presented what the technology was, and I'm happy today to show some more better achievement that we did. This is a project we did in Switzerland, a 17 housing block in Geneva, where we provided our HUKR cement, the N portion, because we have a rapid system as well. And as you can see, we saved over 120 tons of CO2 on that project. Okay. As you can see, our HUKR gives us 115 kilos of CO2 per metric cube of concrete. This is a small figure to explain why our cement, our HUKR slag-based cement, is a key player for the tomorrow's world and even today's world for the countries we're already working in. Because as you see on early stages, our HUKR just behaved the same way as an accelerated CEM2A product, and even better, twice as fast in terms of CEM3B accelerated product. So in terms of using the same materials, using the same schedules on site, we totally fit the requirements of anybody on a construction project. Hence the reason we can do such big projects for now. These are the kind of markets that we actually assess for now. So we obviously have everything regarding office building, housing buildings, and everything. We have CSTB recognition for our concrete with our four different ATEX in France. So even though our cement is not normed because it has no clinker, our concrete is certified by the CSTB and will be shortly also foreign control offices. We work on covering fiber optics using our HEVA technology, which is a calcined clay-based technology. We also work on everything regarding renewable energies for obviously fixing the solar panels or producing some windmills. And also a brand new that we discovered this year was the construction of pools, because obviously water was also a very strategic topic during the last summer, and all swimming pool producers had to kind of buy back their bad publicity. So using very low carbon cement and concrete into their production was also a key element. There would be no sense for us to actually send our cement from Vendée in the west of France to send it all throughout the world. So the way we actually work in foreign countries, once they've obviously tested the materials and tried it in some job sites, is to do some licensing projects. So we actually sell the license so they have access to the technology in order for them to produce the HUKR, the HIONA, the HEVA cement, and the following technologies that we're going to create tomorrow by David Hoffman, by using as local as possible raw materials. And this is the first license agreement that we signed for Saudi Arabia with the Shurfa Group, who are willing to integrate a full system to build their property development system, and obviously providing the Saudi Arabian market. Their plan is to have the first plant, the same tower as ours, by mid-2025, up and running, and another 3 plants to follow and to reach over 1 million ton of production capacity. That would be it for me.
Thank you, Thomas.
My pleasure.
I think we come to. I think we'll come to questions at the end. Our next panelist is Conor O'Rain, and he's from Ecosem. So for those of you who are not familiar with Ecosem, Ecosem is a big supplier of ground slag in Europe. And I think, fortunately, you're not going to talk about traditional ground slag, but about a novel approach that you have. Thanks.
Thank you very much, Ian, for that introduction. So my name's Conor O'Rain, Managing Director of Ecosem Materials. And in the next 10 minutes, I'm going to show you how the global cement industry can reduce its CO2 emissions by 50% by 2030. Now, by the time I finish this sentence, 19,000 bathtubs of concrete will have been poured by the construction industry. And for very good reason. Concrete is an incredible material. It's inherently sustainable. You can design concrete for 120 years lifespan, and it will remain a huge driver of the development of infrastructure around the world. I think that over the next 40 years, there's predicted to be a new New York City in terms of concrete built every month. So a little bit of history about Ecosem. As Ian said, we were traditionally involved just in grinding GGBS and selling it to the concrete industry to replace cement on a one-for-one basis. But we soon realized that there's only enough GBS in the world, the raw material from the byproduct of the production of steel, to replace about 10% of the world's cement. So there isn't enough GBS to reduce the CO2 emissions of the cement industry, in line with the IPCC's recommendation, which is that we need to reduce our carbon emissions by 50% by the end of this decade to avoid catastrophic levels of global warming. So I think I've talked about a lot of the stuff that's in my slides there, but basically the cement industry is not on track to achieve this. I think we're all aware of this, and the presentations over the past few days have cemented this in my mind. Sorry about the pun. Now, as I said, concrete is not the problem, and in fact, cement is not really the problem either. We can make cement today. My colleague from Hoffman just described cement that have virtually no traditional cement in there. The source of the problem is clinker. And the easiest way and the fastest way to decarbonize the cement industry is to minimize the amount of clinker per ton of cement and therefore per cubic meter of concrete. CCUS, we've had a lot of interesting presentations about this over the last few days, but basically, in our opinion, by 2030, the CCUS will play no significant role in reducing the CO2 emissions from the global cement industry. So we need immediate technologies to implement in cement plants to reduce the CO2 emissions now. Now, EcoCem's Act breakthrough technology, for this, my colleagues in the cement industry in the room, you'll be happy to see that we've retained 20% of clinker. We have 30% SCMs. Now, SCMs can be anything like, as I said, we originally focused on ground granulated blast furnace slag, but you can use PFA, you can use natural pozzolans, you can use LC3s. Any SCMs work in this technology. And 50% of limestone filler. Now, this is limestone filler that's been ground to a very specific granulometric curve. And then the real innovation, because I'm sure many of you have seen cements that have this profile before, but the real technology, the real innovation is the chemical admixtures that we're able to use to put this into concrete and retain all of the properties that make concrete the most popular building material in the world. That's my presentation. As Ian said, I'll be happy to answer more questions during the questions round. And if you want any more information, please come and talk to me or come and have a look at some of the websites and documents that I've put up there. Thank you very much.
Thank you, Connor. And so now we're going to have a panelist who is not going to talk about slags. So I welcome David Arthur, who's the CEO of Chasm Advanced Materials. And David, I assume you're going to talk about carbon nanotubes.
I am.
Excellent.
Thank you. Well, I'm here to talk about carbon nanotube additives to enable low-cost and low-carbon concrete the easy and safe way. The mission of our company is to develop and manufacture advanced carbon nanomaterials to create a safer, more connected, and sustainable world. We have two product platforms. The first one is under the ENTEC brand, and it is an additives business. And it consists of reinforcing additives for concrete and electrically conductive additives for lithium-ion batteries. And the second platform is a transparent conductive films business. There are a lot of materials in this world that are transparent, a lot that are conductive, a very short list that does both well. And we make transparent heaters for automobiles, and we also make transparent antennas for 5G and the Internet of Things. So let's focus in on concrete. A common thread that runs through all of our product solutions is a remarkable material called carbon nanotubes. And carbon nanotubes is just one form of carbon. There are many forms of carbons like graphene, graphite, diamond, and soot are all forms of carbon. But what makes carbon nanotubes remarkable is that they're really tiny. They're about the same size as DNA molecules, extremely environmentally stable. They're the strongest materials on Earth, and they can conduct electricity and also heat better than copper. You might ask, then why aren't these materials being used as cement additives today? 3 reasons. No one believed that they could be affordable enough. No one believed that enough nanotubes could be made to make a difference. And importantly, very difficult to work with, difficult to mix into other materials. Our solution is a material called ENTEC-C. We grow carbon nanotubes on top of cementitious materials to make it easier to bring the nanotubes into the cement system. And we can see that at 0.1 weight% loading only can result in dramatic improvements in the mechanical properties of mortars. These are test results that are typical test results that were done at the Center for Advanced Construction Materials at the University of Texas in Arlington in the United States. I'll bring to your attention more than 70% increase in the flexural strength of the mortar samples and almost 30% increase in the early compression strength. These two properties are very meaningful for low carbon and low cost cement. We have obtained similar results for various types of cements across different parts of the world. And we're building right now the lowest cost, most scalable production platform to mass produce these materials at less than $20 per kilogram and at 1,500 metric tons per year scale per reactor. I'll show you in just 1 second that we're delivering these carbon nanotube additives in a way that is easy and safe to use. Our reactor platform uses hydrocarbon gas that we convert into carbon nanotube products and hydrogen byproducts. This is the lowest cost, most scalable production platform in the world. Rotary kiln is the methodology we use, and the cement industry is very familiar with this equipment, and this equipment can be used at very, very large scale. We're at much smaller scale. We don't need to be at quite the industry scale of the cement. You see in this picture, we have a pilot rotary kiln reactor. It's capable of producing 50 metric tons per year of our carbon nanotube materials, and we're building a 1,500 metric ton per year production scale reactor that will be coming online about 1 year from now. This is a brief video in the upper right-hand corner of our carbon nanotubes being continuously produced on our pilot machine. Very simple process that works very, very well and is scalable. We have two basic strategies for integrating our materials into the concrete industry. The first is to directly deposit carbon nanotubes on top of cementitious materials. This places the carbon nanotube materials where you want them, and they adhere very well to the cement particles, and therefore they're easy and safe to use. A second approach is to form granules out of the carbon nanotube materials, where we disentangle the bundles of carbon nanotubes and then tack them together with a water-soluble material. These granules are millimeter scale, and they can easily be added at a ready-mix plant. These are our two ways to integrate carbon nanotubes easily and safely into the supply chain. How do we produce low carbon and low cost? Well, one way is I heard yesterday a lot of talk about use of SCMs, and one of the limitations of SCMs is that sometimes requires a trade-off in the early compression strength. The carbon nanotube materials are very, very high in surface area. In fact, they more than double the surface area of the cement material at a loading of only 0.1 weight percent. So when they're at the surface, they can improve the hydration kinetics, which can improve the early strength quite dramatically, about 30%. So this is a way that it makes it easier to use more SCM materials, therefore reducing cost and reducing carbon. A second way is that one of the weak areas of concrete is flexural strength. That's why steel is used extensively. Just a 0.1 weight percent loading of our carbon nanotubes allows for enough improvement, more than 70% increase in the flexural strength, to reduce the pavement thickness for concrete pavements by 30%. That's a massive reduction in cost and a correspondingly massive reduction in carbon. There are future works that we have underway studying the durability, improvement resulting from our additives. We know from published work before us that this is expected, and we're generating data on this topic as we speak. And we've also demonstrated even smart concrete is possible when the electrically conductive networks of the carbon nanotubes are taken advantage of for piezo-resistive sensing. So in summary, our carbon nanotubes can enable low-cost and low-carbon concrete. Our independent testing of the mortar samples has confirmed that we can improve flexural strength, modulus, and compression strength. The positive results have been realized for several different types of cements, and we have demonstrated adequate carbon nanotube dispersion to deliver this performance using industrial, scalable, and safe methods. We're currently building the world's largest scale and lowest cost production platform for carbon nanotubes, so it will make us relevant to this industry, and we're seeking concrete industry partners and manufacturing partners and licensees to establish the manufacturing capability at various regions in the world. And thank you. Thank you.
So 3 different approaches. Just maybe before we start, in terms of TRL, Thomas, you'd be what, at 9 or?
Sorry?
TRL, technical readiness level.
Yep.
I guess you'd be at either 8 or 9, probably 9, right? Because you're already using it.
Yeah, it's already
full-scale,
used and
yeah?
certified and tested, yeah.
And Connor, would you?
I'd say we're 8, almost at 9. We're testing it with Cemex and concrete in France at the moment.
Okay. And David, you're a little bit before that, I think.
We're a little bit before that,
Yeah.
maybe about 6.
6, yeah. Okay. So taking into account those differences in the readiness level and obviously the slightly different perspective that gives you, what I'd like to ask each of you is where you see the biggest barriers in terms of your discussions with potential partners or potential customers in scaling the use of your solutions. So Thomas, if I start with you.
Well, for me, it's not finding the partners. I mean, we partner with Ecosem as supplier, and we work with similar partners throughout Europe as well. The key element is regulation, basically. Obviously, scaling up, once you find the money to build the facility, once you've tested your materials, and the step 9, I know it's a rough one to go through. So once this is done, it's really making the people ready to use these new materials. We all come with technologies where we try to avoid as much as we can the habits on site, so they can use the same tools, the same materials, the same processes, the same schedule. But then you have the regulation saying, no, you need to have this and this and this and that. So before we can either achieve to get all these norms, if possible, which is not even the case all the time, you need to find the right, mostly main contractors who are willing to do their step and their bit towards decarbonization, and then they actually ask for a low-carbon cement and concrete to use in their platform. And this is why we need these people. We need to spread the word that there's other types of technologies available, and not just one, but a multiple of technologies, and fight these barriers, these regulation barriers.
So when you're talking about regulation barriers, particularly you're thinking about the recipe-based requirements for ready-mix concrete standards, is that
exactly.
right?
I mean, we both part of the AL3C, which is the Alliance for Low Carbon Cement and Concretes, which tries to find the European norms to get either a different norm, either amending the existing norm, so that these norms on cement norms will not be on composition anymore, but on performance of the concrete.
Right, okay. Connor.
Well, first of all, I'm very glad you mentioned scalability, because it's a key point that I forgot to mention in my presentation, which is that the technology that I mentioned there with the 20% clinker, 30% SCMs, and 50% limestone filler can basically be adapted to any cement plant in the world. The most abundant raw material in the world is limestone. So it can be adapted to any cement plant and implemented straight away. The barriers to entry for us, I'm not going to repeat what David said about the concrete norms and standards, or
David is the creator.
In terms of the norms and standards, the big break for us is access to funds. So we need to. We spend $4 million a year on developing these technologies. Of 180 people in our company, 40 of them are directly employed in innovation, which is unheard of as a percentage in the cement industry. We have our own lab in the south of Paris. We have 2 joint labs with the ENS Paris-Saclay and the INSEAD Toulouse. But basically, developing these technologies requires a huge amount of funding. And then implementing them, developing the grinding capacity to produce those materials is another huge step. So we have 2 approaches to this. First of all, we want governments to recognize the impact that we're having on CO2 emissions and the potential impact that this technology can have on a worldwide basis, and therefore help us with the funding, or at least insist on specification. Typically in a country, the government directly or indirectly buys about 50% of the concrete, and they could use their purchasing power to put in place rules and regulations to make people produce low-carbon concrete. The technologies exist to do this. They just need the incentive to be able to do this. And that's it.
Well, not to let you off the hook quite that easily. Now, David mentioned the concept of trying to allow the workers and the usage on site to be done in the same way as conventional cement. Is that also the case with your products?
Yeah, so we recognize that very early. In fact, that's the first, our innovation team is now called the innovation team, but it was called Beyond Slag. And initially, the goal we gave, the objectives we set to the Beyond Slag team was we need something that uses the exact same infrastructure as the concrete industry does now. One of the things that has blocked the development of electric vehicles, for example, is the charging infrastructure that is not in place. And that is still having a detrimental impact on what's the expression, range anxiety, or people, because there isn't enough charging points around, they're not fast enough. So we have worked a huge amount. As I said, it's very easy to make that kind of cement in a precast factory, for example, where rheology and viscosity can be controlled in a very controlled environment, or can be impacted, not impacted because of a controlled environment. Concrete is poured in all sorts of conditions, in all sorts of weather conditions. It has to be pumpable. It has to have the right viscosity, and it has to be décoffré, which in English is dechassed or whatever.
Molding.
Yeah, in 12 hours. So all of those things are key, because we don't want, the last thing you want to do in the concrete industry is turn up with a new product that requires all sorts of different methods to be able to use it. So from the very start, we identified that as a break to the adoption of the technology, and the objective was to not release this project until we had it working the way a normal concrete works.
Okay, thanks, Scott. David? Yes,
Thank you,
Same
Ian.
question.
One of the things that I'm not worried about is scaling the manufacturing platform. We're world experts in carbon nanotube materials. We've successfully scaled this process to the 50-ton scale. We're going another 30x. And the rotary kiln platform that we used is a baby compared to what's used in the cement industry. And nonetheless, can produce 1,500 tons when it's brought online. With that said, we're new to the cement and concrete industry. And so we need partners. We need partners to more fully develop the product solutions so that the materials can be inserted into the supply chain. And we also need manufacturing partners to set up regional manufacturing sites where the material is going to be used. And we're in this region because we're interested in mass-producing nanotubes in this region. And we see a lot of potential for our materials to be used. So it's more, we're new, the material is new, and we need collaboration partners to help us develop the product solutions and get established in this industry and the target regions.
So if I picture using your products, most of the things that we think about using, the things that Thomas and Connor are talking about, for example, and the things that we traditionally think about in the binder mix for concrete, they're all kind of heavy materials, and you use lots of them. And you're coming along with a magic dust, right? That we're sprinkling in half a kilo per cubic meter or kilo per cubic meter. So how do cement manufacturers react when you talk to them about this possibility? Do they believe you? Do they see the opportunity?
There's skepticism. A lot of the cement manufacturers have tried carbon nanotubes already. The data that I showed, although our data is better than what was published 10 years ago, pretty nice data was published 10 years ago. And the cement companies, I think, are tainted for the most part. They've tried carbon nanotubes before, it didn't work, or their laboratory results were impressive, but they couldn't get them to work at a industrial scale. So we have to get past that. And they've respected our data. We've taken their cement samples and we have deposited nanotubes on them. The old-fashioned way, or the traditional way of getting nanotubes to mix into cement has been to prepare a dispersion of carbon nanotubes using very non-scalable methods. And you have a whole bunch of water and a little bit of nanotubes. And you have to transport that material, which is not commercially viable, right? So our way is that we've demonstrated in our laboratory and pilot plant the ability to introduce nanotubes to cement powders and have them stick to those powders. Okay? And so we need to collaborate with cement factories to, what's the best way to do this at a cement plant? And then we are also developing the granules that could be introduced in a concrete mixer, if you will, that with a controlled release of nanotubes once the water hits them and once there's a little bit of agitation. So, and then the nanotubes will end up where you want them, which is on top of the cementitious materials. So those are the two ways that we're engineering. But it's one thing for us to do those things in the laboratory. It's another one to do it at a production scale, and that's why we need the partnerships.
Do you mind if I add to that? So one of the main challenges in Europe to decarbonizing the cement industry at speed is the EU ETS. So the cement industry is disincentivized to rapidly decarbonize because the free allocations don't start reducing until 2026 and they don't fully disappear until 2035. And if you go below your allocation of CO2, you lose those credits for the year afterwards. So they're economically disincentivized to produce, to reduce CO2. And the risk for the cement industry is that handing the keys to low carbon concrete to the concrete industry and to, we have supplied cement, our last innovation, the previous one before this, for XM Ultra, was supplied directly to Vinci who put up their own on-site batching plant on the Athletes Village for the Olympic Games and bypassed the norm system and bypassed the insurance system to be able to, for all intents and purposes, ignore the norms, and were able to produce their own concrete, buy their own cement, produce their own concrete, and build the Athletes Village for the Olympic Games, completely bypassing the cement industry. So the cement industry is at huge risk by not adopting these technologies, and is currently disincentivized from a financial point of view for doing so.
Yeah, I think that the ETS, of course, has some interesting operations. Almost all of them were outside the concept of the original design. So that's one I hadn't appreciated before, but yeah.
Yeah, I wanted to just follow up your comment, which is an excellent one. When we first started marketing this product solution, we were basically emphasizing low carbon. And we were met with not a super warm reception. And when we were able to show the cement and concrete guys that they can reduce cost and improve their margin, and at the same time wave the flag, reducing carbon, we got attention. We only got attention when we could show them that they could reduce cost. And reduce cost and reduce carbon. The reducing carbon bit was frosting on the cake. Getting the foot in the door was reducing cost. And so that's why I think that we might get a stronger pull with our carbon nanotube additive. It's because everyone's interested in reducing cost.
Yeah, sorry, can I just add one thing? So we've been called Ecosem, so decarbonizing the cement industry has been at our DNA since the very beginning, hence the name Ecosem. But for the first 20 years of our existence, the fact that we were eco was actually a negative to selling the product on the market. And we all know GGBS has a host of technical benefits and architectural benefits apart from the CO2 side. But we actually sold it exclusively on its performance benefits. And we called it a post-purchase reward. So after they'd actually buy it, we go, oh, by the way, it's environmentally friendly. Because even today, if you go into a shop and buy an environmentally friendly washing up liquid, usually it costs more and it works less. And that's traditionally, and Tesla to a large extent has changed that thing because, excuse my language, but electric cars were shit before, do you know what I mean, in terms of their performance. But now Tesla's managed to change the game, and that's what we're doing with Ecosem. And all of these technologies are showing that you can have a lower carbon output with huge increase in performance.
I think that's where we stand out a little, is that we focus on the key element is decarbonization and being eco-friendly and environmental friendly. We hammer every day the carbon footprint of our cement and concrete, because for us, that's the key element. That's what needs to change, not just for the industry and profitability and so on, but just for the sake of the earth in general. So we very focus on having this conversation and this main topic, and then the profitability will go as such, with volumes coming up, with carbon credit being more expensive, with energy costs being more expensive. Our cement will just join the price increase of the clinker cement will be.
I'll come back to that, because I think that's an important point that we're seeing in Europe in terms of the price umbrella that cement is giving alternatives. But David, I just wanted to ask you one more question. In a way, I think you probably get compared sometimes to graphene. I'm not sure if that's the case. And obviously graphene has also had some problems in terms of application. It looked very promising in the lab. Do people ask you about that? Is that helping you, or is that increasing the skepticism?
I think graphene is in the middle of a hype cycle, so I think it's sometimes hard to get the signal above that noise, if you will. But carbon nanotubes are, in essence, tubular graphene. They're the same atomic structure, geometry of a tube versus a flat sheet. The different geometries lead to different properties. You have the chemistry of carbon, but the materials are different, and in some cases, we have one precast concrete producer in the United States that's actually blending both materials in order to get the properties. But it's I think there's a perception that carbon nanotubes are too expensive and you can't scale the production, and our production scale and cost is actually superior to graphene right now. And so I think we're kind of changing the view. People kind of pushed nanotubes to the side and say, okay, you know, the next best thing is graphene, and we're changing that view.
Okay, thanks. Thomas, coming back to what you were just saying there, I think last year when we talked about this,
Yep.
you were saying to me that that your products were more expensive than cement, but given what's happened to cement prices in Northern Europe, I'm guessing that might not be true anymore.
It's not true in the UK, for
well,
such.
for example.
I guess instead of a bit of transport and margin, I mean, we're roughly at the same cost today. I was announcing around 250 euros a ton last year. Obviously, with our new plants being built now, and the more volumes we have, and the more partnerships we have, and our products being tested, we can reduce already a little that price. But also with the increase, as I said, of the clinker cements, we're seeing a cross of lines of pricing by 2027. If you add on again the carbon credits that will be payable by then, the increase of energy cost. When ours, we only have 2% of our cost from energy, and we're 50% independent in it. So it's really, really easy for us to have a long-term view of our costing. So I would agree to discuss about how profitability should be key in that element if sustainability was still a trend as it was 15, 20 years ago. Today, sustainability in the construction industry is not a trend, it's a necessity.
Okay, so let's open it up to the audience here and see if we have any questions. Joe, you had your hand up there.
So my question goes to all three panelists. So I would like to know, or to have your idea, how you see your products in, let me say, 10 years or so, yeah? So from Thomas, I would like to know, you said you can produce all the SCMs, yeah? But we know you also do calcined clay. My question to you is, do you see, let me say, a certain trend with what kind of SCMs you will have in 10 years? So from Connor, I would like to know, so you concentrate on slag. Do you think in 10 years you have to move away from slag? And from David, I would like to know, in 10 years, how many of your full-scale nano plants we will see?
Okay, thank you, Joe.
Okay, then I focused on the slag technology that we have today because it's the most advanced in terms of certification and ready-to-use products in terms of concrete into a building site. But you're right, we cannot focus on slag only as a well, it's not SME for us, it's a raw material for us directly. So we focus also on calcined clay, which is products are being actually tested at the same CSTB that the slag one was tested before. We also work on biomass ashes, we're working on fly ash on a different kind of scale. But for us, the key element is not to produce just a slag cement or just one alternative cement, but a full, diverse types of technologies that can be afforded and sourced locally by any partner we will work with.
Anyhow, Thomas, so you can tell us, in 10 years, what proportion is calcined clay of your products?
Within 10 years, I couldn't tell you now. I wouldn't have done that.
So, in answer to your question, so granulated blast furnace slag is not the future. That's quite clear. In Western Europe already, we're seeing by 2026, 50% of the blast furnaces are going to be closed down and turned into electric arc furnaces. So granulated slag will disappear as a material, and as the importance of CO2 becomes a worldwide issue rather than mainly a European or a North American issue at the moment, slag will be used in cement plants and in concrete plants besides the steel plants. So we don't see a great future in blast furnace slag. However, there is electric arc furnace slag, there is basic oxygen furnace slag, and then there's a whole host of other SCMs, such as LC3, which, I mean, apart from limestone, clay is the second most abundant material on the planet, so there'll be a huge development of that. We've got huge resources or reserves in terms of natural pozzolans. Natural pozzolans in the Pantheon in Rome has proved its long-term durability over a couple of thousand years. So that's an available material. And then there are other byproducts from other industries that we are working on at the moment, and I'll tell you about if you sign an NDA and come and visit us in our lab in Champlain.
Thanks. David, how many full-scale plants you will have in 10 years?
I don't have a crystal ball, but if I have to guess, I'm expecting about 10 plants with at least 10 reactors at each plant. Each reactor capable of producing 1,500 metric tons a year. And so 10 regionally located sites with at least 10 reactors. And because the material is only needed at 0.1 weight percent of the cement, that's quite a bit of material.
And do you have enough financial power, or will you also need licensing partners and investors and so on this technology?
Good question. We are raising capital as we speak, and we have investors that are participating in that round. But most of the expansion, our business model is licensing and to form manufacturing partnerships. So we expect the capital for the plants to be from other sources, not from us. We will bring the intellectual property. And it's a very capital efficient manufacturing platform. Only $10 million CapEx is required per reactor platform. So it's a modest amount of capital for the value that can be produced.
I think if the first one works, David, you won't have any problem with the rest.
What's that?
I say if the first one works, you won't have any problem with the rest.
The first one will work. You can count
I
on
don't mean
it.
technically, I mean commercially. I wanted to ask Thomas and Connor this question. So the problems you talked about, Thomas, in terms of the specifications or the product recipe requirements that you have for ready-mix don't apply in precast.
Yeah.
And have you found the precast producers are more open to using that material, or the new material?
Well, precast industry was actually the first partners we had with Soriba and LG Beton in France, who created the first test we made with our low carbon cement. So they were the first partners to kick in, and the biggest ones today in France, and working now closely with European ones to step in as well. Yeah.
Yep. Okay. And Colin, the same question for you.
Yeah, it can be used. It can be used anywhere normal cement can be used. So the challenge that we have at the moment is reducing the 28-day strength, not whether that's in precast or in ready-mix concrete. So it replaces any cement in any condition in any application.
So, I mean, technically, I no doubt that you can make it work, but is there an appetite that you found on the part of the precast producers to adopt the solution?
Yeah, so we actually have the first phase of development going into our plants in Dunkirk at the moment in the northwest of France. That will give us the opportunity to produce 400,000 tons. Those 400,000 tons have already been sold. And a quarter of that will go to the precast industry, and three-quarters of that will go to the ready-mix industry.
And in terms of the application of the product, is the control of the rheology one of the key challenges?
That was one of the main key challenges to start off with. So concrete, the popularity of concrete relies on its properties of use. So it's very easy to pour. You can pour it into any shape, and it turns out right if it's done properly. And that's down to rheology and viscosity. So those are the two key factors you want to control. And obviously the finished concrete, you buy concrete because you want it to be strong and it want it to be durable. So we've made it stronger and more durable than traditional concrete.
Okay. I wonder if I could ask each of you, when you look at how you see the take-up going, I mean, what do you see as the next step in your scaling process? I think, David, maybe I start from you for a change, but you've talked about building the larger reactor. Once you have that larger reactor, you're talking about 1,500 tons a year, right? So if I get my maths right, this is enough for about 15 million tons of cement. Is that about the sort of ratio, or? Yeah. Okay. Sorry, 1 million ton of cement. Yeah. So 1,000 to 1 roughly, or just under. Yeah. How do you see that sort of quantity being deployed? I mean, what would you like to see?
The first thing is, like you said, get the first one running. We're building a demonstrator plant in Norman, Oklahoma, which is where our center of excellence is in the United States for producing these materials. And we'll let partners come in, kick the tires, run the equipment with us, and we'll license the technology and copy these reactors exactly. We can collaborate with the equipment builders to deliver turnkey systems. And we provide the catalyst powder, which is the secret sauce. They connect the hydrocarbon gas and mass produce the carbon nanotubes. So I think we have a very sensible plan, provided that we attract the partners the licensees for them to invest in establishing the regional manufacturing centers. And I think the other thing I forgot to mention is that the same equipment platform can produce materials for concrete and materials for batteries. And there's a massive increase in the use of carbon nanotubes for lithium-ion batteries. If you want faster charging, safer, higher performing batteries, nanotubes are now a need to have versus a nice to have. So there's these gigafactories that are going up around the world are going to need the carbon nanotube materials. So the same plant can serve the battery applications as well as the cement applications, and that reduces the risk of investing in the plant. And so, yeah, we feel good about it, but, you know, we got to execute. We got to execute the
Do
first
you
one.
already have a sort of anchor partners identified for that first plant? There's some partners that will allow you to, so for example, a cement partner that will allow you to sort of start with that plant? Or, I mean, I'm guessing your financiers might ask you that kind of question, right?
We are, the investment round that we have right now is weighted heavily in terms of strategic investors. So these are companies that want to do a collaboration with us and put skin in the game. So, most of the money capital we're raising right now is from investors of that type.
Right.
And we'll build upon that.
Yeah. Okay. So Connor, how about you? How do you see yourself scaling this solution?
So we have a number of partnerships that have already been made public, such as Cemex and the Saint-Gobain Group. And we have a lot of other partnerships under discussion. The key, well, the greatest things about this technology is that there's something for everyone. So if you saw there's 20% clinker in the cement, that means that out of the same kiln, you can get 5 times as much cement. So it's ideal, let's say in the UK, for example, where there's 14 million tons of consumption and 9 million tons of production. So they're reliant on imports, both of cement, but of slag and PFA and stuff like that. So the UK cement industry could be self-sufficient by using this technology. Then there are other places where you need sulfate-resisting cement. This is sulfate-resisting. Chloride-resistant. This is chloride-resisting. So it ticks all of the boxes as well as the low CO2 box. And so I think you asked one of my fellow presenters, where do you see yourself in 10 years' time? The sky is the limit. We need the first movers to to start moving, and then it'll take off like wildfire. Because, as I said, you can produce 5 times as much cement out the same kiln, or you can reduce the CO2 emissions of your kiln by 80% and produce the same amount of cement. You can obey any of the future regulations in terms of the carbon footprint of concrete, the carbon footprint of cement. So there is no limit to the development of this technology, and when we say our new tagline is going to be raising ambitions, reducing emissions, and our stated goal is to reduce the cement industry's CO2 emissions by 50% by 2030. And that is entirely feasible using this technology. And there is place for everyone. All of these are complementary technologies that can be applied worldwide to help reduce to help assist with the decarbonization of the cement industry way before 2050.
Thank you. Thomas?
Well, given the pace we made what we did today. I mean, the company started in 2015 with a first lab, then a pilot plant in 2018, the mixing tower in 2022. We now have our own grinding facilities. We're planning a second plant in the north of France, in Dunkirk as well. We're having this plant being built in Saudi for 2025. So I think the key element is developing new innovation and technologies based on different raw materials, and maybe clay would be the one we'll focus on for the next 10 years. Maybe it will be others, we'll see. And also having a duplicability system, meaning that this tower can be built and based anywhere. We only need 300 square meters of land to a 250,000 ton capacity tower.
Okay. So thank you to all the panelists. I think, the message for the cement industry here is something that we touched on in the very first panel yesterday, in a couple of the other panels yesterday as well. And that is that, this is an industry that is in transition. And we've talked about already the potential, or perhaps the need, to integrate with petrochemicals or the chemical industry on the usage of carbon. But I think another aspect that we need to look at very carefully and ask ourselves what role we want to play is looking at the other ways of making concrete. These approaches have historically been expensive, or historically have been facing the hurdles that Thomas was talking about in terms of product standards. But I think that that's less likely to be true in the future. You can see a lot of product standards changing to allow a wider range of materials to be used. So I think really the message to the cement industry is that these alternative ways of making concrete are really very close to making a significant impact in the industry, and we should consider, what role we want to play in that. So thank you very much. Thank you very much to the panel. A stimulating discussion.